In this nugget, we will learn about the basic lighting calculations that are required to carry out a lighting design. A lighting design helps us identify the most appropriate lighting levels for different environments. A number of factors should be kept in mind while creating a lighting design, such as luminous flux, luminous intensity, illuminance and luminance, color rendering, color temperature, and glare. Luminous flux is the total quantity of light emitted per second by a light source. The unit is lumen. Luminous intensity is the quantity of light emitted per second in a specific direction. The unit is candela. Illuminance is the quantity of light or luminous flux falling on a unit area of a surface. The illuminance is independent of the direction from which the luminous flux reaches the surface. The unit is lux. Luminance is a measure of the quantity of light traveling in a given direction. It describes the amount of light that passes through or is emitted from a particular area. The unit of luminance is candela per square meter. Color rendering is based on how well the 8 standard colors are reproduced by a light source compared to how they are seen in daylight. The scale of color rendering is 0 to 100. Color temperature is a method of describing the color characteristics of light, usually either warm, yellowish, or cool, bluish. It is measured in degrees of Kelvin. Cooler colors are associated with freshness and vitality, while warmer colors are more restful and social. Glare is a visual sensation caused by excessive and uncontrolled brightness. Glare from a lighting installation is always negative. It can either cause discomfort, leading to headaches and eye strain, or it can reduce our ability to see. As we get older, our eye ages and the lens lets less light through, so we need more light to see the same task as we did when we were younger. Veiling glare is stray light in lenses and optical systems caused by reflections between surfaces of lens elements and the inside barrel of the lens. Let us now focus on the key concepts that are required to undertake a lighting design using Dialux Light Wizard. The first and foremost requirement for a lighting design is defining a working plane. Whether it is an office area, car park, or an industrial warehouse, the working plane needs to be defined. The working plane is an imaginary horizontal plane situated at the nominal working height in an interior space. Let us now understand the factors that help in the calculation of direct and interreflected light. The calculations for both the outdoor and indoor lighting design would differ. For an indoor design, the calculations are done for both the direct and interreflected light. However, for an outdoor design, the calculations are done based on the assumption that the light falls directly on the working plane. Also, the lighting level would be calculated according to different reflectance levels, as these would vary from scheme to scheme. The reflectances of different surfaces have an impact on the calculated lighting level. For example, if the room surface is black, reflectance will be 0. For a room with white walls, the reflectance will be 100% and will vary equally when all the surfaces have been changed to white. The numbers are just typical and will vary from scheme to scheme, but you can see how much reflectance influences the final lighting level. Another factor that impacts the calculations for the lighting design is the room geometry. Two rooms with the same reflectance levels, but with different shapes, can produce different calculated results. Next, we will learn about the maintenance factor, which makes a significant difference to the calculated results. This factor is used to determine the depreciation of a lamp or a reflective surface over a period of time. Let us now learn about the concept of grid. The grid is placed on the working plane 0.5 meter away from the walls and is used to calculate the average and uniformity of the light. When reading letters, we need a higher lighting level to see the smaller letters. As the lighting level increases, the background to the letters gets brighter, thereby increasing the contrast between the letter and its background. The better the contrast, the easier it is to see. We use a gonio photometer to determine how much light comes out in each direction from a luminaire. For lighting calculations, We should also know about the photometric properties of the product to be used. The first such property is the lumen output of the lamp or LED luminaire, and the second is the amount of light coming out in each direction from a luminaire. Finally, we need to define how much light we need for different environments. The lighting level depends on a number of factors and is mainly task-related. The harder the task, the more light we need. The available lighting guides help us find out the recommended lighting levels. As a whole, lighting design is partly a mathematical process and partly a series of assumptions based on the needs of the user. So there are many possible solutions, all of which can be correct. Thank you for watching this nugget. You can learn more about these concepts and related calculations in the supporting course on lighting calculation.